Ish, tak nak dah. Pagi nanti lah buat. Macam pun aku je.
Astaghfirullahaladzim, Fir. Buat kerja medik. Aku message kau tu.
Jangan kacau aku lah. Aku tengah main game ni. Cutik kan lambat lagi. Nanti je dah buat. Ish.
Kau tidur pasal lah?
Boleh.
Astagfirullah. Aina? Kau tidur? Apa malam kau nampak tidur dah ni? Tak tidur. Ya Allah, tak tidur kau buat apa?
Tengok live lah.
Kau ni, kau tahu tak? Tidur kena 6 jam, bukan screen time 6 jam.
Good evening. Recent observation shows that students in PKTM Ledang are becoming increasingly addicted to their phone, leading to a sharp rise in daily screen time.
This growing dependency is more than just a habit. It is now a serious issue that affects focus, productivity, and even mental health.
So, just how much time are students spending in the front of their screens? Let's take a look at the data we've gathered. The problem statement of our study is that we, as students of KKTM Ledang, wanted to investigate excessive screen time among the students here, especially at night. Our population consists of all KKTM Ledang students, while our sample include 100 students from different semester and age group. The variable we study include daily screen time in minutes, student hobbies, and their social media usage. From the data we collected, the maximum screen time reached 600 minutes per day. That's about like 10 hours per day. Considering students also spend about 6 hours in classes, this means more than half of their day is spent in the digital world, leaving less time for sleep.
For the data presentation, we created frequency tables, histogram, and argues. From the histogram, the mode was 421.5, representing the highest frequency of the data. From the archive, the estimated median was 339.1. The histogram showed the model class clearly, while the archive helped us visualize the median. Since the mode is higher than the median, this suggests the data is positively skewed, meaning most students recorded lower screen times while some very high values moved their distribution to the right. This proves that screen usage patterns among students are not evenly distributed. Most have a moderate amount of time, but a smaller group spend extremely long hours on their devices, which strongly affects the overall results.
When analyzing the ungroup data, we calculate mean 321.26, median 325.5, mode 86, variance 27,350.432, standard deviation is 165.3797. For group data, the results were mean 324.545, median 339.1, mode 437.1, variance is 28,960.3, standard deviation is 117.177. From this calculation, we can see that ungroup data and group data has a slightly difference in values. For ungroup data, it is more accurate because of the uses of every student's raw values. And for group data, it is less exact but more easy to interpret because of we are using the midpoint. This comparison shows the weakness and the strength for both methods in understanding screen time among the students.
We use Microsoft Excel and remove ungroup and group data. For ungroup data, all 100 raw values were entered directly, and Excel function like average, median, mode, bar, and estimate were used. For group data, we organize the data sets into class intervals and calculate using midpoints. This made it easier to visualize pattern with histogram and audio. By comparing the results, the mean difference was small, which was 3.285, showing group data was still represent the central value fairly well. The median difference was larger, which was 16.57, meaning group data is less accurate for identifying the middle value.
For variance and standard deviation, group data give higher values, showing it tends to overestimate the spread due to midpoint use. In conclusion, ungrouped data is more precise but harder to manage with large data sets, while group data is easier to summarize but slightly less accurate. Both methods give us useful insight into student street time and show how excessive usage can affect daily life.